1.2 Angle relationships and similar figures. Vertical angles. Vertical angles have equal measures. The pair of angles NMP and RMQ are vertical angles. So we're talking about NMP. So NMP, we're talking about this one right here. I'm gonna get a different color. That's horrible. NMP. Right, so it goes NMP. And then we have RMQ, so RMQ. Those are vertical angles, meaning they're across from each other. That's what that means. So they share the same vertice. Parallel lines are lines that lie on the same plane and do not intersect. When a line Q intersects two parallel lines, Q is called the transversal. So here's a picture of that. We have two parallel lines, and then the red line, that's the transversal. That's the one that cuts the parallel lines. So there's something special about that when we have a transversal. Now, angles and relationships. This is reaching back to geometry. So alternate interior angles. So alternate interior angles are when they're on the inside and they alternate from one each other. Another form of alternate interior angles would be right here. Those would be alternate interior angles. The angle measures are equal. Alternate exterior angles, pretty much the same thing except they're on the outside. So we'd have one right here, and then we would also have another pair right there. I'll use that a different color. Right here. Interior angles on the same side of transversal. So those are called not corresponding. Sorry, those are called interior angles. There's nothing there. I wasn't going to say anything. Never mind. Forget what I was saying. So interior angles, when you have two interior angles here, here, also here, and here, they add up to 180. So the two angles, so angle 1 plus, or whatever angle it is. So the measure of angle 1 plus the measure of angle 2, that's 180 degrees. Corresponding angles are angles that are like kind of in the same position but on top. So you see how these are on top of the parallel line? So they're corresponding angles. Another corresponding angle we would have here and here. We would also have here and here. And then last, we would have here and here. So those are all of our corresponding angles. We're going to find the measure of angle 1, 2, 3, 4, given that lines M and N are parallel. So pretend that this wasn't there. It doesn't say that. We cannot assume M and N are parallel. We can't assume that. It either has to tell us it's parallel, or it would give us this little thing right here. It would give us like a little inequality sign. So that's exactly. So if you see that sign, it also means parallel. Okay, so let's look at our two angles of 1 and 4, because that's what we're given measures for. We're given values for those. So angles 1 and 4. So let's figure out, are they corresponding angles? Are they alternate interior angles? Are they alternate exterior angles? So they are alternate exterior angles. They're alternate exterior angles because they're on the outside and they're like in opposite spots. So alternate exterior angles tell me that the angles are going to be equal. So angle 1 equals angle 4. So let's actually set that up. So we have angle 1, which is 3x plus 2 degrees. We don't need the parentheses or the degrees. You can just get rid of that. You can just do 3x plus 2. And it's going to equal to angle 4. Angle 4 is 5x minus 40 degrees. Here we're going to solve for x. So we subtract 3 to both sides, 3x to both sides. We're left with 2 equals 2x minus 40. Add 40 to both sides, so we'll have 42 equals 2x. Divide by 2. And we get x equals 21. So that's what x is. That's not the angle, that's just what x is. So we have to plug it back in. So let's plug it back into angle 1. So angle 1, we have 3x plus 2. So we have 3x x, which is 21, plus 2. So 3 times 21, we get 63, plus 2. So 63 plus 2, we get 65 degrees. So we have the measure of angle 1. It's 65 degrees. Now, do we have to go in and plug 21 into angle 4? No, we don't have to plug 21 into angle 4. Why? Because angle 1 equals angle 4. So we know angle 4 is 65 degrees. So we have the measure of angle 1, which is 65 degrees. We have the measure of angle 4, which is 65 degrees. And that's because they're equal. So now we have to find the measure of angle 3 and the measure of angle 2. So if we look at the measure of angle 3, they share the same vertice. They're across from each other. 1 and 3 are across from each other. Since they share the same vertice, they are the same value. So angle 1 and angle 3, since they're vertical angles, they're the same. They're the same measure. So we know the measure of angle 3 is also 65 degrees. So all we have left is to find the measure of angle 2. Now we have nothing across from it. We don't have any corresponding angles. We don't have alternate interior angles for 2. So what we can do is use kind of the rule that interior angles on the same side of the transversal equal 180. So you see how these two are on the same side of the transversal? They're on the same side of it. So when we add them together, it's supposed to equal 180. And that's what that is saying. See how these are on the same? That's why they equal 180. It's a line. It's a straight line. Because if we just take this out, if we just look at that part, it's a straight line with an angle right there. So that's why it equals 180. So the measure of angle 2 is 180 minus 65. And we do that because it's a straight line. That also means this would be 115. We don't have to find that, but we're just doing it. So that means that's 115. This is 115. This is 115. So we found, see how all the numbers are the same? We have 65 and 115. All of them are going to be 65 and 115. Why is that? It's because we have parallel lines. Parallel means same. Parallel means same because they're the same line. They're just in different positions, top and bottom. So parallel means same, meaning you're going to have the same values. All right, the measure of two of the angles of the triangle are 48 and 61. Find the measure of the third angle. So we're talking about a triangle. So triangle, it's the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. There's only 3 angles in a triangle. So we're going to add them all up to equal 180. So we have 48 degrees plus 61 degrees plus x degrees. We don't know it, so it's x equals 180. We're going to combine like terms, so add the numbers. Another way that we could do this after we add up all the numbers is subtracting 180 from these. So you could also do 180 minus 48 minus 61, and that's going to give you your x. Or you can set it up as all the angles equal 180. This is how I do it. I set up all the angles to equal 180. Now, why do I do it that way? That's just because I know that when I add up all the angles, it equals 180. So it's easier for me to think that way. So we have 48 plus 61, which is 109 degrees, plus x degrees equals 180 degrees. All right, we're going to subtract 109 from 180, and we get x degrees equals 71 degrees. So this measure right here would be 71 degrees. All right, types of triangles. We have an acute triangle, meaning all acute angles. So all angles are under 90 degrees. We have a right triangle, which means one is a right triangle. And then we have, or a right angle. And then we have an obtuse triangle, which has an obtuse angle. If I give you this, can you say that's a right triangle? Nope. Do not assume. Do not assume anything in math unless you have concrete evidence, but you're not assuming. You're using proofs, and you're using theorems, and you're using postulates to prove your assumption, but you're not assuming here. But in this case, when I draw a triangle that looks like a right triangle, it doesn't mean that it is. This could be 91 degrees. How do I know? I don't know. So unless it says it's 90 degrees, or if it has that little box, then it is not 90 degrees. Do not assume anything in this class. You have to have a reason why you're saying what you're saying. So it has to say 90, or it has to have that little box. All right, more types of triangles. You have equilateral triangle when all sides are equal, isosceles triangle when two sides are equal, and then scalene when it's just a weird, normal, like random triangle. These little tick marks meaning all three sides are the same. So you see how these ones only have one? That means those two sides are only the same. And on scalene, this has 1, 2, and 3. That means none of them are the same. Conditions for similar triangles. For triangle ABC to be similar, the triangle DEF, to triangle DEF, the following conditions must hold. Corresponding angles must have the same measure, and corresponding sides must be proportional. That is, the ratios of their corresponding sides must be equal. So for it to be similar, the angles have to be the same, and the sides have to be proportional. So in the figure, triangle ABC and NMP are similar. It tells us, awesome. Find the measure of angle B and C. So let's find the measure of angle B right here. And then we're trying to find the measure of angle C, which is right here. So it's proportional, or sorry, it's a similar figure. So what we're going to do is look for the angle that kind of matches up. So the angle that matches up with C is P. So the angle C is 104 degrees. So it's similar. That means that they're going to be the same. So measure of angle C is the same thing as the measure of angle P because they're in the same position. Now, I want you to go ahead and pause this video and find the measure of angle B. So go ahead and find angle B. Alrighty. I hope you tried it. I hope you tried it. It's okay if you didn't, but I really want you to. So we want to look what's in the same place as B. Well, it's M. So the measure of angle B is the same thing as the measure of angle M. So angle M, that was 31 degrees. And there we go. We have our answer. Alright, example 4. Given that the triangle ABC and triangle DFE are similar, find the lengths of the unknown sides of triangle DFE. So we're trying to find all the unknown sides of DFE. So we need to find side DF, and we need to find side EF. Now, sides are not identical. They're proportional. So we're going to set up a proportion. Only angles are the same. So sides, we have to set up a proportion. So let's figure out what we know. So let's match up sides. So DF, it's proportional to AB. EF is proportional to CB. All right, let's find EF first. So what we want to find, I'm going to put it on top, EF. So EF on that triangle of the one with EF, we have a known side. The known side is ED. So we're going to use the known side always, which is ED. So this is part of the same triangle. This is part of the same triangle. Then it's going to equal, so the corresponding side to EF is CB. And then the corresponding side to ED is CA. So let's go ahead and put in our values. We don't know EF, so it's just EF. We know ED. ED is 8. And that's going to equal CB, which is 32, over CA, which is 16. Now we cross multiply. So when we cross multiply, we have 16EF equals 32 times 8. So we have 32 times 8 is 256. We're going to divide by 16. So we have EF equals 16. So EF is 16. All right, so now we need to find DF. So that's what we need to find. So we don't know DF. We don't know it. So that's what's always going to go on top. Whatever you don't know, put first. So always put that first. So then the corresponding side to DF is AB. So I'm going to use the value that we have on the small triangle that was given. Try to use given values always. So the given value is ED. And then the corresponding side to ED was CA or AC. AC, CA, it doesn't matter. I see it as CA. All right, let's fill in our numbers. We don't know DF, so we can leave it as DF, or we can switch it to X. It doesn't matter. You can use X. Before we didn't, but you can. AB, that is 24. And that equals ED, which was 8, over ACCA, which is 16. From here, we're going to cross multiply. So we have 16x equals 8 times 24, which is 192. Divide by 16, and we get 12. So DF is 12. Example 5. Workers must measure the height of a building flagpole. They find that at an instant when the shadow of the station is 18 meters long, the shadow of the flagpole is 27 meters long. The building is 10 meters high. Find the height of the flagpole. Okay, so we need to find the height of the flagpole. So this, we need to find this right here. So that's x. So we don't know it, put it on top. Why are we setting this up as a proportion? Because we're working with similar triangles. How do we know we're working with similar triangles? Because it's comparing the two. It's comparing the two shadows. So we're going to set this up as a proportion. So we have x. X is MN or NM. Doesn't matter how you say it. So the corresponding side to x is that side, which is 10. And then that's going to equal, so the side that we have on the big triangle is 27. And the reason why we put the big triangle on top, because that's what's already on top, was the big triangle. And then the corresponding side to 27 is 18. From here, we just cross multiply. So we have x times 18, that's 18x. 27 times 10, that's 270. We divide and we get x equals 15. So that's not our answer. 15 is just not, that's not our answer. It's not. They ask in words. This is a word problem. They ask in words, so you have to answer in words. So we say the flagpole is 15 meters high, tall, doesn't matter. I'm going to say high. Why do I use high? Because they use the word high. That's why. And meters, because they are giving us the units in meters.